Hey everybody, good to see you guys again. We're gonna do the first 4 examples on 7.8. You guys can copy those from my key that I provide on Google Classroom, but this is an explanation of the examples. Seeing if I walk you through it, it'll make a little bit more sense. Pretty challenging day. Again, we have 8 examples total in 7.8. We're only gonna do the first 4 today and try a little independent practice with them. Okay, so number 1, you guys, you look at it and you're thinking, well, man, this is way harder than 7.7. Because in 7.7, we always had equals 0. Well, now we don't. So our number 1 goal is to get everything on one side. And if everything is on one side, the other side obviously has to have nothing. Now, it doesn't matter if you have things on the left side or the right side. That doesn't matter at all. But we want our x squared, or our biggest power, to be positive. So you guys, when I look at this, I want to leave x squared on the left side because he is already positive. So when I do my line of equality, I realize that I can't have the 18 on the right side. So to get rid of a piece on either side and move it, we use add or subtract. So I get rid of 18 by subtracting 18, but now I have to think about where should I put him. Can't put them underneath x squared, they're not like terms. Can't put them underneath negative 3x, not like terms. But if you go back and you look at all of your previous problems, we learned about descending order. And since he doesn't have an x, he should be put after both of those. So I kind of squeeze in minus 18 after the 3x. Now on the left side, I have 3 pieces of math. X squared minus 3x minus 18. There's an equal sign on your line of equality, and the right side is now 0. This will take us to now 7.7. If you go back in your 7.7 notes, you'll realize, hey, I got to get a times problem equals 0 by my 0 product rule. This is MA bottoms up. Hopefully you're getting a little bit better at factoring. We've been doing it for like about the last 3 to 4 weeks even. So we go to an MA bottoms up. M, 1 times negative 18. The add number, negative 3. Now here's where it got tricky. You need to make sure you have the 2 special numbers that work. You can pause it and think for yourself. But you should get positive 3 and negative 6. They multiply to negative 18. They add to negative 3. And once you have that, that unlocks the problem. We set up 2 parentheses that both start with x. Special number, positive 3. Special number, negative 6. We can't forget the equal sign and the 0. Now we do have to remember to divide by the front number. Divide by 1. Divide by 1. So now that becomes x plus 3 times x minus 6 is equal to 0. And I can do my 0 product rule. Front equals 0, back equals 0. When I take x plus 3 equal to 0 and x minus 6 equals 0, I get 2 solutions. Minus 3, answer is negative 3. Add 6, answer is positive 6. All right, so let's try that on number 2 now. So number 2, you might be thinking, oh, that's the same type of problem as number 1. Yes and no. But the fact is, I don't have 0 yet. So when I look at it, I'm like, oh, everything has to be on one side. And I locate the biggest exponent, and I want him to be positive. Well, x squared is on the left, and he's already positive. So I have to keep him there. So I need to make this side 0. We can move a piece with a variable by addition or subtraction too across that equal sign. So the opposite of positive 4x, to get rid of him, I will minus 4x on both sides. But now I have a place for him to go. He's a like term with positive 3x. So I'll minus 4x right underneath him. This will leave me with x squared, and I get to combine like terms here. Positive 3x minus 4x is minus x, and that equals now 0 because these cancel. Okay, so I like the fact that I have equals 0, but I need to factor now. 7.7, we learned that if you have a complicated math problem equals 0, you can factor it or turn it into multiply. Now, which method is this? If you look back at your 7.3 greatest common factor, this should look like that. Since he has an x and he has an x, they have something in common. The greatest common factor is just x to the first. When they have letters in common, you choose the smaller exponent. Now to get the leftovers, it might be a little tricky, but you gotta divide. So remember, go back up here, show divide by x. The solution should be x. There's a minus sign. And when you divide by x, a lot of kids are kind of confused. They think nothing goes there because they always say, well, those x's cancel. But remember, they do have big numbers or coefficients, 1 and 1. So the 1 divided by 1 is 1, and yes, those x's do cancel. And that equals 0. We cannot forget the equal sign or the 0. Now we can do our melody. Front equals 0, back equals 0. And solve them separately using the 0 product rule. That variable is isolated. We're going to add 1 on both sides for positive 1. All right, you guys, those are the basics. Now again, we're just going to get a little extra help with numbers 3 and 4. Today, we're going to do 4 examples, and then we're going to try some independent practice. Rewatch this video. If you watch it a couple of times, it might click. Number 3. When we have 2 is equal to 3y squared plus 13y plus 14, we'll realize that we have to get one side to be 0. Well, when we do that, we have to know which side to make 0. And we locate our biggest exponent, which is squared or y squared, and it's positive. So we want to keep him there. So we need this side to be 0. Well, how do we get rid of the 2? By subtraction. They will cancel, making 0 equals. But on the right side, I need to know where to put it. I would put it underneath a like term. So it should go right underneath that positive 14. Now I'll make a new right side. 3y squared stays the same, plus 13y stays the same, but the right side becomes plus 12 after that. Now we look and we're like, well, okay, we need to make a times problem, because a times problem has to equal 0. Well, which method of factoring should we use? And it's MA bottoms up. So if you guys look at that, those are just y's instead of x's, not a big deal. So I'll kind of do that work right over here. I got m and I got a. The m number, front times back, is 36. The add number, 13. Pause it and see if you can come up with the special numbers. The special numbers are 4 and 9. They times to make 36. They add to make 13. So now that I got my special numbers, I complete the process for MA bottoms up. I keep my 0 equals. I can't drop that. Still an equation. But now I go 2 parentheses that both start with the letter Y, positive number, or sorry, special number positive 4, special number positive 9, but I divide by the front. Divide by 3, divide by 3. That is 0 equals, I get 2 new parentheses. Here it's a fraction, so we do the bottoms up. That is just a nice answer of y plus 3. Now you guys, we can go front equals 0, back equals 0. To save time, I'll jump to the answers, but you can follow my notes. I'll minus 4, and then I'll divide by 3. I would prefer to keep it a fraction. I'll minus 3, and I'm done. Again, you'll see the work in my notes, and hopefully that will help you out. Okay, last example of the day, number 4. We have a squared minus 2a minus 25 is equal to negative 2a. Sometimes people think about factoring a little bit too early. They think this is going to be an MA bottoms up problem because that's a trinomial, but we got to wait and see what happens. So we want our a squared to be positive. We'll keep him there. So we can't have the negative 2a on the right side. We need one side to be 0. So the opposite of negative 2a is add 2a. Now I look on the left side and see if there's any like terms for me to put him underneath, and there is. So I'll put him underneath the other a part, and something special is going to happen. Well, on the left side, we know they cancel. We want 0, so that's why we did that. But on the right side, as I start to do my math, I bring the a squared down, but negative 2a and positive 2a also cancel. These go away, and I bring down my minus 25. But now that I got equals 0, I do need to get a times problem. And you guys, this would be DOS, or difference of squares, section 7.5. Circle the minus sign, fork the front, a times a, fork the back, 5 times 5, and you will get two different solutions, or two different factors first. Remember, the front fork goes in front. The back fork goes in back, 1 plus 1 minus. And that equals 0 still. Don't drop your equals 0. Now, front equals 0, back equals 0. This is the time, oops, sorry, it's letter A, not X. Whenever you can leave your answers separate, or since you have a -5 answer and a +5 answer, you could write it as A equals plus or minus 5. I hope this explanation helps out. Again, you could copy the notes straight from Google Classroom, but watch these videos. Pause them a couple of times. See if you know the next step, and then that'll help you with your independent practice. All right, you guys, hope to see you soon. Again, if you need anything, please reach out to me and I will try my best to help you. All right, it's your boy, Mr. P. See ya.